Weathering usually works alongside another process called erosion. Erosion is the transport of rock or soil, usually by wind or water. Weathering breaks rock into small pieces and erosion carries it away. Rock particles are not carried forever though, so eventually they are deposited somewhere else, which creates the dynamic landscapes that we see all around us, as rock is moved from one place to the next. Liquid water, ice, wind, and gravity can all cause erosion. The water on Earth is constantly moving, whether in rivers, streams, the ocean, or underground, and as it does so, it collides with rock and rock particles. If the moving water carries enough force to move the mass of a rock, whether a minute particle of silt or a massive boulder, it can cause erosion. Streams and rivers can pull earth from the banks and grow wider, or from the river bed and dig deeper, carving their way through the land. The energy in ocean waves, undertow, and currents pick up and carry sand and small particles and deposit them in other places, causing beaches to change and sandbars and even islands or peninsulas to form. If the area is made of harder rock, you'll see cliffs form instead of sandy beaches. However, the energy in the water will eventually weather and erode those as well. These are just some examples of the erosive power of water and the unique physical structures it can create. Ice cannot move as quickly as liquid water, but it can cause rock to move, so it is also a potential agent of erosion. In particular, glaciers, which are large sheets of ice, have tremendous erosive power. They move in a couple different ways, and as they move, they can take large chunks of earth with them, carving divots and large canyons into the earth. First, as the earth cools and warms, the massive glaciers tend to grow and shrink. When they grow, they push through the earth and can cause erosion. When they shrink, we can see the results left behind. Glaciers grow where it is cold enough to snow, but never warm enough for them to melt, so ice piles up. As it grows thicker and thicker, the pressure created by its own weight causes the very bottom to melt or crystallize. If the glacier is at elevation, gravity can make the whole glacier slide downhill on this liquid or crystalline layer. Glaciers that form in mountain ranges, called alpine glaciers, are especially known for moving in this way. These rivers of ice are especially known for eroding large U-shaped valleys through mountainous areas. The other type of glaciers, continental glaciers, are more known for creating depressions in the earth, most of which are now lakes. The Great Lakes between the United States and Canada are one example. Gravity only works as an erosive agent when significant weathering has weakened the rock's hold on the earth beneath it, or when wind, water, or some other erosive agent starts the rock moving downhill. Landslides, mudslides, and the slow creep of soil and rock particles are all examples of gravity-driven erosion. Landslides and mudslides usually don't begin unless something starts them, but once they do, gravity can cause massive amounts of earth to move quickly downhill. The pyroclastic flow and lahars discussed earlier are examples of such gravity-driven erosion. They don't start, though, until the energy from the eruption starts the rock moving downhill. Creep is much slower. It is the slow creep of loose sediment downhill, similar to the slow movement of an alpine glacier. Neither wind nor gravity can match the erosive power of water, but both are still notable erosive agents. Wind can move small rock particles from place to place, and this movement can cause larger rocks to weaken through abrasion. If you've ever gone to the beach on a windy day and felt the sand being blown against you, then you've felt wind erosion at work. Once the wind stops blowing, or when the particles hit something that the wind cannot move, such as a sand dune, a rock, or tree, the sand is deposited and begins to pile up. The sand dunes of deserts are constantly moving and changing because of wind erosion. The picture on the left is a sand dune, and the right is a landslide. You can see the difference between the windward side of the dune and the leeward side. The slow push of individual sand particles over the ridge of the dune, and over again, actually causes the entire dune to move over time. If you're ever lost in the desert, don't use the sand dunes to navigate, because they may not be in the same place from one day to the next.